student, welcome now for the second part. This is the part of logarithm. When we were in Form 2, we covered this part that when given an expression like 2 times 2 times 2 times 2, let's say, this is the same as to say 2 power 4. The same as in exponent. This 2 is an exponent or index, but we know this 4, I mean, while this 2 is base. A combination of 2 and 4 together is always given the name power. But now, let us check the result upon taking 2 times 2 times 2 times 2. The result in this part is 16. Therefore, we simply write as 16 equals to 2 power 4. Our intention here, we want to know the name of this number. This number, clearly we know this is a base, exponent, combination of this is called power, but this 16 is the one we give the name product, or sometimes we simply call mathematically called logarithm. So this is the one we call it logarithm. So we write as 16 is a logarithm of 4 to base 2. So we simply write as 4 equals to logarithm of 16 to base 2. Mind you, our level is advanced level, particularly from 5. We could not waste our time trying to talk about identify the base and the logarithm and the exponent and the logarithm of a number. It could be wastage of time. Therefore, as far as the level is concerned, here we are going to directly to check with the law of logarithms, laws of logarithms, laws of logarithms. We are going to condense them together. Let us start with, we say, consider one who has given you like x equals to a power m and y equals to a power n. Suppose you write this in logarithmic form. Mind you, these are expressions existing in exponential form. So we want to make them as a logarithmic form. This could appear as m equals to logarithm of x base a. Call this is equation 1. And this could become as n equals to logarithm of y base a. Y base a, that is n. Call this is equation 2. Now class, when we are given x and y, as it has been expressed here, what could happen if you take x times y? What are you getting? While we know that the value of x is a power m and the value of y is a power n, we say taking x times y, this is the same as to take a power m times a power n. You know why? Because the value of x is a power m and the value of y is a power n. From the law of indices, this is the same as to say a power m plus n. It means when we want to express this in logarithmic form, we could be taking m plus n equals to logarithm of x times y base a. But we know the value of m and n from equation 1 and 2. Let us call this is equation 3, and then we say put 1 and 2 in 3. Putting 1 and 2 in 3 class, it will appear as in the place value of m now is when we write logarithm of x base a plus in the place value of n we have logarithm of y base a. This equals to logarithm of xy base a. So the rule says multiplying logarithms with the same base is the same as adding the logarithms of the number expressed with a common base. Or we can say adding logarithms of the same base is simple as multiplying. So this is the first rule. Rule number 2, we say suppose we take x divided by y. X divided by y from here, one could take a power m divided by a power n. This is the same as to take as a power m minus n. So x over y, we can call this is equation number 4 anyway. But we know, writing this in logarithmic form class, what is happening is simple as taking the entire as an exponent. So we have m minus n equals to logarithm of x over y base a. But we know the value of m and n as from equation 1 and 2. We say here in m, directly we write logarithm of x base a minus logarithm of y base a in n equals to logarithm of x over y base a. This is another rule. Here the reason behind we say 1 and 2 in 3. That is where it is coming from. It means 1 and in 4 we can call. In 4, yes, we can call in 4. 1 and 2 in 4. We have been repressing. This is rule number 2. Very much important class, which is so interesting. Now let us look again another law. This is from, we say, when you have x equals to a power n, which is equation 1. Suppose you decide to write this in logarithmic form, which is clearly n equals to logarithm of x base a, call this is equation 2. Now from this one we say applying logarithm, let's say applying exponent m in 1. Yes, that is so good. Applying exponent m in 1. It means from equation 1, I could write x power m and here a power n power m. You know, from the law of indices, we have not changed the meaning. Upon using reciprocal rule of exponent, these m could be cancelling. And now here, we simply have x power m equals to a power n m. When we have this expression, we can decide to write this in logarithmic form, assuming this as a single number. We could have n times m equals to logarithm of x power m base a. Now let us call this is equation number 3. But then we have the value of n from 2. The value of n, this is known as logarithm of x base a. Now it means we want to replace in this n here class. What is appearing now? We simply have this much. It means we have m equals to, m logarithm of, we have kept m, n now is the one replacing this, logarithm of x base a equals to logarithm of x power m base a. This is called logarithm of power. This is called logarithm of power. Now, we just make it simple like this. That when we have logarithm of x power 1 over n base a, this could become 1 over n logarithm of x base a. This is another rule. Simply from logarithm of power, this is called logarithm of root. Logarithm of root. Again, we could simply say, we know when you have any number power 0, let's say a power 0 is 1. Now suppose you treat this writing in logarithmic form. We could be simply having 0 equals to logarithm of 1 base a. So clearly we say logarithm of 1 to n base is always 0. Logarithm of n base, logarithm of 1 to n base is always what? 0. It means 1 is giving logarithm of 1 base 20, the answer is 0. Logarithm of 1 to base 60, the answer is 0, etc. This is another important rule here. Another rule, we say, suppose you have any number, say a power 1, is always what? A. We know when you take expressing the exponent 1, to any number, it will be giving the same result. Now suppose you want to treat this one, write it in logarithmic form. We could simply taking this 1 equals to logarithm of this a base a. This rule signifies that the logarithm of any number to the same base is 1. It means logarithm of 2 base 2, the answer is 1. And whatever the case, wherever there exists the same number and base, the answer is 1. Okay. Now, student, let us check rule number 7, how it works. Rule number 7, here we always say expressing logarithms into common base. Expressing logarithms into common base. When we were in Form 2, we used to treat expression like logarithm of a base b equals to logarithm of a over logarithm of b. You know the reason behind. We are expressing a logarithm into common base, and our common base here is base 10. But that is not the case. It is not a necessary condition that you will always have to express with base 10. You can choose any suitable base, which is good enough for you to solve your question, depending with the nature of the question that will be given. Now we say, suppose given x equals to a power m. Here we say, call this is the question 1. When you want to write this in logarithmic form, it will appear as m equals to logarithm of x base a, and then this is equation 2. And here we say, suppose you apply logarithm to this equation 1, say to base c, any base. We say, I have said, mind you, is not a necessary condition to apply base 10. You can apply any base, any suitable number which is good enough for you, for which can make you easy to finish up your question. Suppose here we apply logarithm to base c, let's say. This could be logarithm of x base c equals to logarithm of a power m to base c. When you bring this m here from the logarithm of power, it means it will appear as logarithm of x base c equals to m logarithm of a to base c. Now when you want to divide by this expression, divide both sides by log of a base c, it means we have m equals to log of x base c over logarithm of a to base c. Now let us call this is equation 3. Checking carefully from up, you will see from equation 2 here, wherever there exists m, it signifies logarithm of x base a. So I'm replacing this m by logarithm of x base a, and we now have this expression class, this equation, which will have log of x base a equals to log of x base c, log of x base c, I mean, this is x, yeah, and then over log of a base c. Here it was log of x base a. Our a has appeared as a log, but our base, which is now c. Now we can be working with this rule class. Very much important. Okay. Let us again switch for another rule. Then I'll pose some good questions, which will be summarizing all the rules together. Let's look now rule number 8. Rule number 8. This one we call it reciprocal logarithms. Reciprocal logarithms. Reciprocal logarithms. It says, when you have logarithm of a base b, when you reciprocate, when you put 1 over, they are going to change. The base will appear as a log, as a number, and the number will appear as a base. Now this is a rule called reciprocal logarithms. The rule is so useful. We want to prove this. One can say, where does this come from? Class, can you guess? Where are we getting from here? When you take log of a base b, is apparently 1 over. Now they are changing. Where is it coming from? Can you ask yourself, where are we getting this? Okay, now let us go with me. You will see how it is interesting here. We say proof. proof on this. We say clearly, when you have log of A base B, we know from rule number 7 is the same as log of A divided by log of B. Here, we have expressed this logarithm using base 10. Again, now you have log of B base A. This will appear as log of B divided by log of A. Call this is equation 2 again. Now if we taking 1 times 2, what is going to happen, class? When you take 1 times 2, it means you'll be taking multiply in that order. This side will be multiplying the same side for the second equation. In the same way also for the second part. It means we are taking the first part times this. It means here we have log of A base B times log of B base A equals to log of A divided by log of B times log of B divided by log of A. Yeah, you can see equation 1 times equation 2. Class, if we check here, what is happening? You will see that this is a typical identical parts, which is just cancelling. And then we will notice that this side is strictly giving 1. Now we have, if this side, since this side is 1, we can go with this intermediate step. Since this side is 1, if I decided to divide by this factor both sides, see, it means we are going to have this part here, logarithm of A base B equals to, here is 1 divided by log of B base A, which is reciprocal rule. Hence proved. Proved as required. Proved as required. Now let us check some worked examples. Worked examples. With all the rules which we have touched involving the part of logarithms, we are now able to introduce some questions which will be requiring the application of these rules in combination of all together. We can then solve some questions. Let us check one of the question. One says solve for x. We are given here logarithm of x square equals to log of x brackets square. To solve this question, class, is easy. Maybe can I ask you, how can you solve this question? Where can you start with? If you check here, there is an exponent of 2 appearing to only variable x, but in this part, the exponent is taking the entire log x. To solve this one, we proceed like this. First of all, go with the law of power. Bring this 2 backward. It will appear as 2 log of x equals to log of x, here what? Square. But here we say, let log of x, call it as a. We are going to have 2a equals to a square. One could say, let us divide by a both sides, which is mathematical meaningless. To solve this one, we insist to collect like terms together. So bring 2a to the other side. It means here we could have a square minus 2a equals to 0. Now here the best approach here, class, do not divide, instead factor out common factor. Here, the common factor here is what? What is the common factor here, class? If you check carefully, it means this is 2. It is a, I mean. So I'm taking a out. We have a minus 2. Solving this, our a gives 0 or our a gives 2. Mind you, our question does not involve a at all. Our a was just introduced purposely to make this problem solved. Therefore, we know a is what? What is a? Our a is signifying logarithm of x. So we say, but log of x equals to a. So, log of x equals to 0 or log of x equals to 2. But there is base 10 here. We call it common. Expressing logarithmic form into exponential form, it means we are just taking what? 10 power 0 equals to x, or 10 power 2 equals to x. And then any number power 0, it is giving what? 1. We are now able to conclude x is 1 or x is equals to 100. You can see how it is interesting. Where 100 is coming from is simply taking 10 times 10 repeatedly. That is why now. So we get two distinct results from the question. Okay, let us look now for the second example, and this will be the last one for this part. Welcome. Okay, student, let us check another example too, which is just the combination of the idea of logarithms, which we have seen. Suppose one says solve for x. Then you are given a question like logarithm of x base 3 plus logarithm of 9 base x equals to 3. This is a very interesting question. You remember from one of the national exams some 2 to 3 years ago, we had this question, which is too good. To solve this question, where are we supposed to start? If you check the nature of the question, what can you deduce from this question, student? If you check carefully from this one, you will realize that there is a variable which is appearing as a number again as a base. To such counter question, we are always trying to apply the concept of reciprocal logarithm. So here we say solution. We will have to recall. We say recall logarithm of a base b equals to 1 over logarithm of b base what? A. It means you have changed from reciprocal logarithm. So we say thus, from our question here. Here, I can just write 1 over logarithm. I'm changing this. So I'm taking 3 base what? Base x from this rule. And then here plus. We know 9 is 3 square. So I can just write 3 square base x equals to 3. Again, from the law of power, these two can come backward here. We then have 1 over logarithm of 3 base x, 2 plus times 3 base x equals to 3. If you check this one, class, it is easy to say there exist two parts which are just congruent or identical, we say. So I can simply say let logarithm of 3 base x, let it as what? As a, let's say. It means we are going to have 1 over a plus 2a equals to 3. Avoiding denominator, multiply by a both sides. When you multiply by this a, it will be making linear equation with no denominator at all. Denominator just 1. So you have 1 plus 2a square equals to 3a. Arranging this is a quadratic about a. So you have 2a square minus 3a plus 1 equals to 0. We just need to make factorization by splitting the middle term without loss of generality. If you take this 2 and 1, it means it's 2 times 1, 2. So the numbers which will be fitting for splitting the middle term is -2 and -1. Okay, we now have something like 2a square minus 2a minus a plus 1 equal to 0. Factorizing this, bring 2a outside, is a minus 1. Bring -1, a minus 1. So let's take the outer of the factors. It means we will have 2a minus 1 and another part which is a minus 1. Solving this from the properties of real numbers, it will give our a is positive 1 over 2 or a is 1. Mind you, our intention is not to solve a. A is just an assumed variable. It is signifying what? Logarithm of 3 base x is a. So in the place value of a, just plug log of x, log of 3 base x. So we say log of 3 base x signifies a equals to 1/2, or log of 3 base x signifies 1. Converting logarithmic form into exponential, you'll get x power 1/2 equals to 3, or x power 1 equals to 3. Class, when we are in this position, how can you conclude the value of x the way you see? Who can tell? How can you conclude the value of x here? Because we are having x power half, 3, and x power 1 is 3. How can we conclude? Anyone to tell? Okay, I accept it. It is true. What we will do, we will just have to apply the law of index here. We'll say power 2, power 2. These two will cancel with these two. From the law of power, we are going to have x equals to 9. 9 comes from 3 square. Or, we know any number power 1 is just that one. So we just take x equals to what? 3. Therefore, two distinct results will be concluding for our question. You can see how it is interesting to know the part of logarithms. Now, let me take you to the classwork. Classwork, it will be the combination of exponent and logarithms. One can say, solve for x given 4 power x minus 4 power 2x plus 4 equals to 0. 2, solve for x again. You can have 2 power x equals to 4 power x. Is a challenging one. Just a hint, use graphical methods. I can give you hint. Use graphical method. It will be the easiest solution, the easiest approach, I mean. Question number 3, solve again here. For x, we can say logarithm of x power half equals to logarithm of x brackets power what? Power half. Question number 4, one can say simplify completely. You can have logarithm of x power 14 minus logarithm of x power 3 divided by logarithm of x power 7 minus logarithm of x power 2. Question number 5, it is an interesting one. One can say if a plus b is 10 and a square plus b square is 80, one can say prove that logarithm of a plus logarithm of b equals to 1. Another question, you can say, given, you will see this from Advanced Mathematics by Tranta, given that logarithm of a base b is c, logarithm equals to b, here we will have a, base, logarithm of c base a is b, and logarithm, here we will be having a, and here we will be having c, so this is b. Logarithm of b base c is a. Then one says prove that a times b times c equals to 1. You will see this from Advanced Mathematics by Trant. Okay. Student, thank you for watching. I appreciate. Now we have ended our lesson today with this question being given. Next period, I'll be coming with a part of series. But before I start teaching, I'll first highlight the concept on this part. That means the question which I have been given. Thank you very much.